The article that I researched was called Organ Printing as an Information Technology. I found it on a website called Science Direct, and it was published by the Presidia Engineering Journal. The article basically talks about organ printing, which is described as a computer-aided layer-by-layer biofabrication of functional tissue based on digital modeling with the use of tissue spheroids as the building blocks. To build the organs and the tissue, there are 3 steps, which are pre-processing, processing, and post-processing. For the pre-processing, there are 3 different approaches that could be taken. One of them in which is our computer would be used to make a blueprint of the organ, which will be done with the use of bioimaging and ultrasound. And by using this method, it would be able to demonstrate the anatomical information specific to the patient in need. However, this process has not reached a cellular level, and the tissue composition and cell redistribution is not as precise as needed. Another approach would be done by the reconstruction of the histological section, which would provide resolution and information about the organ, such as the size, the shape, and the composition. However, organs available are only available after the death of a patient, which means that they could change or possibly distort. And the third and final approach would be the mathematical computational anatomical model, which basically is, if you know the mathematical composition of the vascular branching, the organ in need would be able to be reconstruction. It was found that success in making the organs would rely on the combination of all 3 approaches. For the processing, the first step would be the computer simulation, in which it's the virtual representation of the cell sorters, the robotic tissue spheroid fabricator, the robotic bioprinter, and the perfusion bioreactors. And then after that, they would be virtually placed into a building according to the processes of each of the equipments. And the steps to the bioprocessing and organ bioassembly were simulated on a micro level and integrated with the virtual equipment in the buildings. The post-processing starts after the bioprinting process, and it ensures the viability and survival of the 3D bioprinted organ.